Alright, so for my first second hours, I'm gone today. Basically, we are working on some standards-based grading stuff for next year. So just a little recap from yesterday, that one example that I showed you. Now, you don't have to draw the picture here, but basically what we have is a point, and we're going to basically tell you the 6 trig functions from that point. Here's that point. Here's the triangle made. Now, I showed you this yesterday, so that's why I'm going a little bit quicker. We went 6 to the right and 2 down. The big thing that I want you to remember, though, is that the x value is the adjacent side, the y value is the opposite side. When you do that, then all you need to do is find the hypotenuse. That's where we use a squared plus b squared equals c squared. So I have 6 squared plus negative 2 squared equals c squared. That's 36 plus 4 equals c squared, which is 40 equals c squared. And don't forget the square root at the end. And you get c equals the square root of 40, or, which is 6.3. All right, that's like doing the actual math work of it. And once we have the hypotenuse, then when we're doing our 6 trig functions, I have my adjacent, which is my x value, which is 6, my opposite, which is my y value, which is negative 2, and then my hypotenuse, which is 6.3 that I found. And then we have our 6 trig functions: sine, cosine, tangent, and then cosecant, secant, cotangent. All right, so sine theta, that's just going to be opposite over hypotenuse. So that's negative 2 over 6.3. Cosine theta, which is adjacent over hypotenuse, so that's 6 over 6.3. Tangent, which is opposite over adjacent, so that's negative 2 over 6, which simplifies down to negative 1 over 3. To get these ones, you just flip. So to find cosecant, you flip the sine one, so that's just 6.3 over negative 2. For secant, you're just flipping the cosine, so that's 6.3 over 6. And for cotangent, you now have 6 over negative 2, which is negative 3 when you simplify. All right, so for that first example, it's a lot like we've done before when we have to find the 6 trig functions. This is just the procedure. You don't have to draw the picture. Honestly, you just need to remember that the x is the adjacent, the y is the opposite, and you need to find the hypotenuse using Pythagorean theorem. Moving on then. Here we have reference angles. All right. So what you have to do, first off, we're going to sketch where 210 is. So 210, I know that this is from 0 to 90. This is 90 to 180. Here's 180 to 270. So 210 is somewhere here. All right. And then if I look at this little key thing, I'm in quadrant 3. So this right here is the reference angle they're talking about. So what is this distance? That's their question. All right. Well, here's 210. Right there's 210. Here is 180. So I would do 210 minus 180. What is that? 30 degrees. That is my reference angle. All right, that's what you see right here. Here's the angle minus 180. That's what you would have to do. All right, so for 210 see that's in the third quadrant. So you're doing 210 minus 180. For negative 110, well, from 360, I know it's a negative, so I have to drop down. Well, there would be 90, so I'm going to be in the third quadrant again. All right, so what is that angle right there? So I'm going to do theta, which is negative 110, minus 180. The issue with that is you're going to get negative 400 and some, and we're still not sure what that is. So if I knew this was negative 110, if I add 360 to that, that'll tell me what this side is right here. So that would be 250. So negative 110 is equivalent to 250. And now I can find this angle right here by doing 250 minus 180. And I get 70, I believe. Yep, 70 degrees. The negative one's a little bit more difficult. You really have to think about, okay, where is this actually? Like, what is that part? What I would do is figure out the positive part of this. That's using the coterminal knowledge. And then taking that number and minusing it from 180. The last part, if you have radians. Now, there's a couple things you can do. One, you could just convert this to see the degree, or you can say, okay, I'm going to use my unit circle and figure out where 2 pi over 3 is on the unit circle. Where that is the second quadrant. There's your 2 pi over 3. Second quadrant says 180 minus theta. So 180 minus theta, or pi minus theta. So what you're doing is you're basically taking away 1 pi from 2 pi. So what you're left with then, if I was going to convert this, probably a little bit easier. You have 180 minus, this converted is 120 degrees. So 180 minus 120, and you're left with 60 degrees. That is your reference angle. These three parts right here are all the reference angles. All right, so basically for these questions, you're drawing them, and then you're telling me what's the actual reference angle. Right there, right there, right there. The last part now, and a lot of this we did yesterday, you have this part of using the unit circle, actually going through the unit circle, looking through it. So for this first one, cosine 240, I'm going to look on my sheet to figure out where cosine 240 is. I have a little one right here. Now I filled out one. So 240 is right here. I know that cosine is the first coordinate, so that's negative a half. So the answer here is just negative 1 over 2. All right. Now for things like cosecant, you got to think about, what does cosecant go with? It's the opposite of sine. So I know sine 5 pi over 6 is equal to 1/2. So that means that cosecant 5 pi over 6 is just that flipped, so it's 2 over 1. All right, so that's how you'd have to do that one. Sine 3 pi over 4, so sine 3 pi over 4, I look for where 3 pi over 4 is. Sine is the second part of the ordered pair. So that tells you that sine 3 pi over 4 is the square root of 2 over 2. The biggest thing I need you to know for right now is, can you get the cosine and the sine? We'll work on cosecant, secant, and cotangent later. So then looking at number 13, that's the last one that has sine. We'll just go over that one real quick. I would look for sine 11 pi over 6 on my unit circle. What is the second ordered pair? Well, that's 1 over 2. All right, we'll worry about 11, 12, 14, 15, 16 tomorrow. 32 then. We're looking at reference angles. Here's a little bit of a word problem. You will have a word problem like something like this on the assessment. So it says a soccer player is X feet from the goalie. He kicks the ball towards the goal as shown in the figure. The goalie jumps up and catches the ball 7 feet in the air. find the reference angle, then write a trig function that can be used to find out how far the goalie, the soccer player was, from the goalie the soccer player was when he kicked the ball. All right, so here we have the 7 feet. That's our opposite. Here's our adjacent. We need to find this angle right here. That's what they're talking about for the reference angle. Well, to do that, we're going to do 180 minus 154. And that's 26 degrees. So our reference angle, the angle we're going to use, is 26 degrees. So that's answering part A. And then now we're going to do tan 26. Why tan 26? We have the opposite. We're looking for the adjacent. So it's tan 26 equals opposite 7. Adjacent is x. And now you are solving this. So tan 26 in the calculator is 0.4877 equals 7 over x multiplied by x on both sides. And then divide by 0.4877. Like that. And our x equals, when you do that, about 14.4 feet. So our kicker was about 14.4 feet away from the goalie when he kicked the ball. All right, so that's how you're going to do one of those problems. You will have a problem like that on the assessment, just seeing, all right, can you take what we're talking about and apply it. This is 12-3. Some of it we worked on yesterday. That's it for you. Next up, we have a little bit of a partner quiz, so you can work with a partner on this quiz and hand it in. It's more just to see where you're at. It's not going to go into Skyward, but do your best on it, please, and thank you.